What's up, my peeps? So, today I've decided I'm back and I've got my Zevia grapefruit flavored. I have my hyperspeed coding mustache, and I'm going to teach you more Go concurrency patterns. Part 3. So, today we're going to be talking about one of my favorite, really, I think probably the only way that you want to do custom long-running Go routines. So let's say that you have a gRPC service, you want to maintain that client, but you also want to maintain some kind of connection to a database, like you would some kind of like object relational thing. This is how you would do it. I'm also going to talk about context, how to propagate contexts among Go routines, and yeah, let's do it. So first things first, let's build a producer and a consumer. That producer is just going to send integers via a for loop to some kind of consumer that will print them. Okay, so what did I do here? Well, we have a function producer. It takes a single argument, which is a channel of integers. And then we have a for loop. And so we're saying between 0 and uninclusive 100, so between 0 and 99, we have a select statement. That select statement has a default, and that default is sending whatever I is over that channel. So now we need to make some kind of consumer that will consume off of that channel, because this is putting things onto the channel. So let's make a consumer. So what did I create here? Well, consume takes the exact same argument as producer, and that's just the integer of channels that we're doing something with. Here we have another for select, and here we have the case of in case we get a new integer upon that channel. So what's really key about this argument right here is that we're doing an assignment. So whenever Go has an assignment, it creates a copy. This is what's called a non-blocking channel operation. So this channel will block until there's a function that is taking something to take something off of that channel. Where if your function is busy going and doing some really complex logic, if you don't do the assignment, you can have a blocking channel. And when you're doing concurrency operations, you don't want to have blocking channels. Go is all about creating copies because it's a garbage collected language. Just make a copy. It's far more expensive to try to worry about it otherwise. So let's tool out main now and see how this works. So here we have this functionality. Why do I have to insert time.sleep? Because main will actually exit and return before all of the Go routines have been executed. So let's see what this looks like. Right. So we produce, as you can see, 1 through 0 all the way up through 100, all consumed. It waited time for 5 seconds before it exited out, and all of that is great, cool. So now we literally just created a very simple program that has a producer and a consumer, and both of those are Go routines. Nothing crazy here, but of course this is really poorly done, right? What if you want to cancel under certain conditions? What if you want it to stop early? There's all kinds of logic here that we could play around with. So I'm going to create a case where, let's say that we have 2 consumers. right? But we have one producer. So remember, once something gets consumed off of the so now I want to create separate cases where let's say that the number 34 happens, and then I want to cancel everything else. Like I want it to be done if once I reach the number 34, once at least I print the number 34. So let's handle that case now. So now look at what we've done here, right? So we made a new channel, and we called it done. So what is that doing? Well, done is blocking, right? Go routines that don't do an assignment block until something is received. Great. So we basically said, hey, on consumer, we have a case here where we're taking off a new integer. If that new integer is equal to 34, then I want you to send done over that channel, and then we will receive upon here. And what happens once it's not blocking, right? It's not blocking anymore. It's received something. So then we just return, and we're done. We can see that here. Right? So hey, consumer done. So we know that once we receive 34, we wanted to end that consumer. But remember, they block until they're done. All the go routines will, done will block until it receives some kind of signal. Well, here we had simply too many of these copies, and it overloaded, and it was just like, oh, hey, well, I didn't receive done until I had already printed everything. That's the nature of go routines, right? That's why you have to have some kind of blocking channel in main, or whatever function is calling all of these go routines, because otherwise that function will return before all of the go routines are done, because go routines are really, really, really fast, and because they're all happening kind of at the same time. So how do we sort of solve that? We do a cancel, and we do that via a context. So let's put context in here and see how this changes things. Okay, so let's look at what we did here, right? We created a context with a cancel. So that's basically saying, don't just give me back some kind of context that I can track, also give me a cancel function that I can call if I want that context to be done. And you have to give it some kind of context as a reference point. Context.background is typically the most common. Now, if you had a go routine that was calling many go routines, that was calling many go routines, you would always just use the parent context associated with it. And then if one context down the line gets, of this tree of go routines that you've created, gets canceled, it can propagate up and out. It's very, very handy when you're doing really, really high concurrency, really high parallelism work. It makes it really, really easy. So let's run this and see what happens. Probably delete that. Hey, look at that. Things ended a lot sooner. So what happened here? Well, we got to here, but we still printed 3 or 4 numbers before the done was propagated and was able to cancel out everything. Also, don't forget to close your channels. So that gets propagated out. So that cancel, so the cancel gets propagated via these switch statements, which if you're doing any kind of Go routines, like structure them like this, it really does make things a lot easier. Just use for selects. They're non-blocking. They make they're type independent. All you have to do is really give them a channel to receive on, right? So I could technically have 50 channels that I'm receiving on this single Go routine. That makes it really handy for, say, tracking where certain pieces of information are going. Really, really handy stuff. So I want to show you one more case. And what if we had multiple consumers? Now here I call it Go Consumer and Consumer 2. Technically there's no reason why you would really need to do that. It's totally legal to call multiple consumers on the same thing. The only reason I'm doing it here is just to be a little more explicit as to which function I'm calling and why, but that's a way that you can actually save yourself on some boilerplate. So here we see consumer 1 called to cancel. And here we can see consumer 2 called to cancel. We can also see here that the numbers are far more out of order. And we can also see that we printed far more. So imagine we have multiple consumers taking things off of the channel. That operation's happening really, really quickly. So we're able to consume more information before a context cancel is propagated. It's very, very interesting behavior. So imagine these channels as just sort of, they're just queues. That's it. It's the same thing as Kafka. Once you have something that's taken off of the queue, it's removed. And so there's no reason why you can't have 4, 5, 6, 7, 10 of these all running at the same time. And just, just pops it off, creates a copy, and life is good. So yeah, use for selects, use contexts. It's pretty slick.